Hi, welcome to my Google Kaggle Capstone presentation where I talk about how we used generative AI in a medical clinic setting where we generate synthetic data and use the generated data to retrieve case histories for patients. So let me scroll down and let's go to the problem. In medical clinics, doctors may encounter challenges in tracing the medical history of a patient and also the kind of treatments they previously prescribed to patients with a similar medical condition, which could be useful for other patients with a similar condition. So, what we see here is an image of an old school patient history card cabinet where doctors need to sift through each card one by one and in order to trace and to retrieve the history card for a particular patient that they are interested in. So in this article, we will demonstrate how we used Google Gemini to generate synthetic data and retrieve that synthetic data that we generated. So let's scroll down. And in part one, we will cover synthetic data generation using Gemini. So, in terms of the process flow at a high level, what we did was to initialize two Gemini models. First is Gemini 2.0 Flash. So, this model is used to generate each medical transcript in text form. And the text format would be structured in JSON. Then next, we also initialized another Gemini model, which is Gemini Text Embedding 004. So this embedding model would ingest each medical transcript in text format and output a version of that transcript as an embedding. And that is needed to, and that embedding is used in the Chroma DB vector database later, which can be used to retrieve relevant or similar case histories based on those vector embeddings. So, so that's number one, to initialize our Gemini models. Then number two, we also initialize our Chroma DB vector database, which would store our medical transcripts later. And next, we move on to step number three, where we generate medical transcripts. So in this case, we generated 1,000 medical transcripts, out of which we have 100 patients and 10 medical transcripts per patient. So after we generate each batch of medical transcripts, which will be 10 transcripts per patient, we store them as JSON files under step number four. Then in step number five, we generated embeddings based on those text transcripts. And based on those embeddings, we saved them. We saved the text as well as the embedding versions of the transcript in Chroma DB. And let us scroll down a bit. So we went through our first Gemini model, which was to generate medical transcripts in text, and a second Gemini model, which converted the medical transcripts in text format to embeddings. So next, let us move on to our code in Jupyter Notebook on Kaggle. All right. So this is our first notebook where we generated synthetic data to use in our analysis later where we can implement information retrieval. So in this first notebook, let me scroll down, where over here we try to install the required packages. Then next we move on to importing the packages over here, and also importing our Google API key in order to use our Gemini API. Then next, over here we try to initialize our Google API client using the key, and we also initialize some basic configuration, which is to allow retries of querying or trying to reach out to the Gemini API in case there are rate limits. So by allowing retries, it allows our text generation process to continue in a batch. And over here, we also explore the kind of models available to us. And if you recall, for the content generation model, which generates medical transcripts in text format, we used Gemini 2.0 Flash, which is the best model available so far and free for text generation. And next, we move on to explore the kind of embedding models available and is free to generate embeddings from the medical transcript text. And what we see, let me just scroll down a bit, is that there are four models available, and out of which there are two which are not in experimental stage, and out of which 004 is the latest that is available. So that is why we chose to use text embedding 004 to work on embeddings. And let us scroll down. So before we generated the 1000 medical transcript passages, we tried to create 10 passages for just one person. And what we did here was to try to configure our Gemini model with a temperature of 0.5, which is somewhere in the middle in terms of creativity for the model. Because if we set the temperature as too high, like let's say at 0.9, what we observed was that there could be different patient names across the 10 medical transcripts. So we had to try and reduce the creativity of the model and yet still allowing for a little bit of creativity to in order to have some sort of diversity instead and when it comes to the clinical notes later. So in terms of the prompt we used, we asked the model to generate 10 medical transcript entries for one patient. And in terms of the name, we asked the model to generate fun names such as mango enthusiast over at the top and below. And in terms of the medical transcript, we enforced a strict JSON format where out of the 10 entries, so each entry would be a dictionary. And in terms of the fields in the JSON, we would have the name, the address, the date of visit, the medical condition, the consultation notes, and whether a medical certificate was issued. And next, we move on to the requirements we specified to the model. So again, we specified that we wanted fun names for all 10 entries, and we wanted dates between 2022 to 2024, and in each entry we wanted different medical conditions. Then we also specified realistic addresses in Singapore, and at the same time also check that there are truly 10 separate transcript entries. So we would input the prompt as well as the creative configuration in our Gemini 2.0 Flash model. And what we observed was that in terms of the names, yes, the names across all 10 entries are the same, and they have the same address, and that the date of visit and the medical condition, consultation notes, and whether a medical certificate was issued were different. So somehow this works. And next, we move on to creating 1,000 passages for our Chroma database. So let us scroll down. All right. And before we create the 1,000 passages, we need to create an embedding function which would initialize our text embedding 004 model from Gemini. So recall that we want to allow retries of the Gemini model. So we added that here. And next, so we initialize this Gemini embedding function. And we use that in our Chroma database later over here. And we initialize our Chroma database client over here with a name of Chroma Medical DB. And next, after initializing our Chroma database, we move on to creating some helper functions, such as one to clean our Gemini JSON response. And next, we initialize a transcripts directory where we store our medical transcripts in JSON format. And we create that directory if it has not been created. Then next, we created a helper function to sanitize file names. And next, we define this generate patient entries function, which, if you recall in an earlier section, we tried to create the 10 passages for one particular person. So what we did was to refactor that code from that section to here for in order to generate each batch of 10 medical transcript entries. So next, we use that function in this process batch function to generate our 1,000 passages. And let me just go through what it does. So for each batch of 10 medical transcripts, we generate over here. And we also have a safeguard where we try to check if the number of entries are 10. And if it is not 10, we ask Gemini to generate another set of 10 entries again. So out of the 10 medical transcript entries, what we did was to prepare the file names over here. And next we saved each medical transcript as a JSON. And next we also saved our medical transcripts in ChromaDB over here. And we also generated embeddings from the embedding function, which does a conversion from the medical transcript text format to embeddings. Then that is over here. And we use the embedding to store in Chroma database. So our Chroma database actually stores the medical transcript in embedding format as well as in text format over here above. So next we scroll down and we did this transcript generation process for 100 patients. And let us scroll down to the end of the notebook. What we observed was that there were 1,000 medical transcript entries generated, and we did a sanity check against ChromaDB, and yet there were 999 JSON files saved. So we will try to address this difference in one JSON file later in our blog entry under section 3, challenges. So this is the end for notebook 1. So let us move back to the blog post, and we will move on to our second notebook, a high level overview of what we do in the second notebook. So in notebook 2, we try to implement information retrieval using a technique called Retrieval Augmented Generation. So in terms of the process flow at a high level, we initialize our Gemini models first. So we initialize the same Gemini models, Gemini 2.0 Flash and the text embedding 004 model. And next, we initialized a medical RAG class, which we would explain in notebook. And in that class, we also initialize our ChromaDB connection and some functions to implement some of these search functionalities later. So that's step 2. And in step number 3, we implemented a functionality which allows doctors to search for medical transcripts using a patient's name. Then from that search process, we use the response to put into another Gemini model, which helps to summarize and format the output in a way that is much simpler for a doctor to understand and retrieve a patient's medical history. So that's number 3. And in terms of number 4, we look at another use case where a doctor can search for medical transcripts with a similar medical condition. So over here, based on the search that is generated, we put that into another Gemini model to verify and fix the output, and subsequently return the response to a doctor in order to assess the treatment for patients with similar medical conditions. And we will move on to notebook 2 next. So this is notebook 2, where we explore retrieving user information using the RAG technique. So let me scroll down, and over here we installed the libraries, and let us move up a bit. So we installed the libraries, then we imported the libraries over here, and same thing, we added code to allow retries to the Gemini API, and we also brought over the Gemini embedding function, which would be used in our Chroma database later. So first, we look at how we can retrieve medical transcripts for a selected person using their name. And before we even do that, we need to initialize or define our medical RAG class. And what this class does is to connect to our Chroma database over here. So our Chroma database has this path, and we also put in the Gemini embedding function, and that would set up our connection to the Chroma database. And next, we implemented three functions. So first, we defined the search by name function, which searches for medical transcripts using the name. And second, we have another function which searches for similar medical transcripts based on a query that the user passes in over here. And by default, we have set this to return the top 5 medical transcripts. And if you need, you can define how many transcripts you would like the function to return later. And next, we also define a third function which tried to get the unique names which have been stored in our Chroma database, which we use to do a sanity check later. So based on the class that we just created above, now let us initialize it, and we did a sanity check of the number of collections in our Chroma database, and it is 1. So what this means is that there is one collection of 1,000 medical transcript records. And over here, what we tried to do was to check for the medical transcript IDs which are in our Chroma database over here. And we tried to get the first 20, and out of which we just need the first one as an example, and use that here to get the first medical transcript. So we can see the ID of the medical transcript here and the information which has been stored. And what I need from the transcript is the name of the user, because recall we are trying to search for medical transcripts using a patient's name. So I needed Mango Tango person 1, and we explored different ways to search for this person. So first we searched using a partial name like Mango Tango, and it failed. Then next we searched using lowercase, and it failed. Next we searched using the exact name of the patient, and finally Chroma database returned the medical transcripts of this person. In this case, there was only one medical transcript. And let us scroll down. So over here, we can see that Mango Tango person 1 has this medical transcript, and the information can be quite difficult for a doctor to understand, especially with the embedding information that we scrolled down from. So what we wanted to do was to pass that information in here into a variable and put that in our prompt, which we would subsequently pass to another Gemini model to interpret and structure in a way that is much easier for a doctor to analyze. So what we did in the prompt was to ask this new Gemini model to summarize the user's transcripts and output in the format that is showing the name first, followed by the address, the medical conditions, and a summary of visits. And below, we also have a list of information for each visit. And in each visit, the kind of information we want would be the visit date, whether a medical certificate was issued, and the file name of the medical transcript, which was saved in JSON format. And if there were multiple visits for the patient, what we wanted was visit 1 above and another bullet point for visits 2, 3, and so on. And let's say within each visit, that is when we have the information presented above, nested inside. So we passed that to a Gemini 2.0 Flash model, and the response we got was great because now it is in a format that a doctor can understand. So we have the name, address, the conditions, and the summary of a visit, followed by a list of information for each visit. So in this case, Mango Tango person 1 only visited the doctor once. So there is only one visit information over here. And so that's the first functionality which we demonstrated basically where we tried to retrieve the medical transcript for a patient using their name. And next, we briefly did a sanity check of the unique names or persons stored in Chroma database. And apparently, there were 111 unique patients. So we will address this in section 3 of our blog post under challenges. And next, we will scroll down to here where we will look at how we retrieved transcripts with similar medical conditions. So if you recall in our medical RAG class, we created a similarity search functionality which accepts a query string. In this case, a doctor can search for patients with hypertension. Then we run that, and in this case, recall that we retrieve a default of the top 5 medical transcripts with this medical condition. So you can see the 5 IDs here. And we scroll down. As you can see, the information is very difficult for a doctor to understand. So what we did was to put that information into another Gemini model over here. And we asked that Gemini model to summarize the information which we passed to it, where if there are multiple persons, they can nest in terms of name 1, 2, 3, and so on, followed by their information. And for each name, the kind of information we wanted was the address, a list of conditions, summary of visits, and a list of information for each visit. So below, we also looked at asking our Gemini model to sort according to person number, which is over here in ascending order. And we also asked the Gemini model to think step by step when it comes to counting the number of people with the medical conditions. So we added this in because previously the model encountered hallucinations when it came to counting the number of patients that it retrieved. So we also asked the model not to output unnecessary text on its reasoning plan. So we passed that prompt into a Gemini 2.0 Flash model, and this is the response we received. So here is a summary of the medical transcripts, and we have person 1, 2, 3, 4, and 5. And if you recall, we asked the model to sort the responses based on the person numbers in ascending order. So what we see here is person 41 at number 5, and yet person 90 is above person 41. So that is clearly incorrect. And we will try to address this later when we look at sorting by visit date and how we solve this issue. So let us move on to the next part where we sorted by visit date. And in this case, it is in descending order over here. And the rest are pretty much the same. And what we retrieved from the model was that the model output its reasoning plan, which we asked it not to. The model also calculated a wrong number of persons, and at the same time, the sorting order was wrong because we wanted descending order in terms of the visit date. So here is 2024, then 2022, which is fine. However, once you go to visit number 5, this is 2023. So that is wrong. And what we tried to do was to take the response given by this model and put that in another Gemini model. And in the prompt that we give to this new Gemini model, we ask it to perform the role of a checker and to fix issues in the previous response. So we ask this new model to check the count of names in the summary and to check that the sort order is in descending order in terms of visit date, and if there is anything that is incorrect, we ask that the model will update the count and the sort order. And next, we also asked this model to remove any unnecessary text on reasoning plans. So we put that into a Gemini 2.0 Flash model, and the response we received from this model was this. So we received the summary, which is great. So there are 5 people, the count is correct. At the top, we do not have a reasoning plan. And below, if you see here, the visit dates, we have 2024, followed by 2023, and next 2022, 8th November, then another 2022, 8th November, and the last visit was 2022, 22nd July. So great. This subsequent Gemini model fixed all 3 issues we identified earlier. So that is the end of Notebook 2. Coming up next, we move on to our blog post where we discuss some of the challenges we encountered. So let us move on to our blog post again, where we look at section 3, the challenges we encountered. when using Gemini and the ChromaDB vector database. So in 3A, we look at how at the Chroma database level when we tried to retrieve patients using the patient name, what we observed was that we could not query for just partial names or names in lowercase. And that is challenging for a doctor because maybe we just want to search for particular patient using their names in lowercase and just partially that, like let's say Mango Tango in lowercase. So hopefully ChromaDB can offer such a functionality, and or maybe it could be something that we need to learn how to use. So that's one. Then secondly, we observed that for Gemini or large language models, it could be susceptible to hallucinations. So what this means is that if you recall just now when we did sorting on the visit date or by the person numbers, Gemini was unable to sort in the right order for all records. So what we did to fix that issue was to add a verification step by sending the first Gemini's response to a subsequent Gemini model in order to verify and fix the count of patients, as well as the sorting order. And next, we move on to the third challenge, where sometimes large language models have challenges following our instructions. So over here, we asked the Gemini model to sort on the visit date in descending order and hide its reasoning plan. However, it was unable to do that for us for that first model. So we had to, same thing, add a subsequent verification step using a second Gemini model to fix the first model's response. So that kind of discusses the challenges we encountered. And in terms of future work that we can explore, we can use such verification steps to fix other issues which we encountered in our notebooks in future. And that could involve verifying and fixing the medical transcripts generated. Because in this case, even though there were 1,000 medical transcripts generated and saved in ChromaDB, there were only 99 JSON files. So maybe one file could have some formatting errors and therefore it was not saved. So maybe we can fix that file and save it in both the database and as a JSON file. So that's the first item. Second item, maybe we can fix the patient names generated. Because if you recall earlier on, the Gemini model generated 111 unique names when we did a sanity check against the Chroma database. So maybe we can add a verification step to ensure that the names are correct across all 10 transcripts in each batch before we save them. Then third, let me scroll down. So number 3, we can also ask and possibly explore verifying and fixing the number of medical transcripts per patient, because what we encountered was that in our scenario, sometimes one person can have one transcript and another person can have as many as 11 transcripts. So That is different from our instruction of 10 transcripts per patient, which we input to Gemini. And that kind of sums up the work that we can explore in the future, which is to add verification steps to improve the kind of basically the way that Gemini models can follow our instructions. And to conclude, our implementation has demonstrated how Gemini can generate synthetic data and retrieve relevant patient information in clinics. And to end off, let us also move on to Notebook 2, where we discuss the kind of capabilities we have demonstrated in Notebooks 1 and 2. So, if you recall, for this capstone, we needed to showcase at least 3 GenAI capabilities. So, let me show the kind of capabilities we showcased in Notebooks 1 and 2. Okay, here we look at the GenAI capabilities covered in Part 1 and Part 2 notebooks. So in Part 1, we demonstrated how we can generate structured outputs in JSON format. If you recall, where each JSON is a medical transcript. And we also looked at how we can generate embeddings, which we store in Chroma database. Then we also, so the Chroma database is a vector store, which we have demonstrated as well. So those are the 3 concepts we covered in Part 1. Then in Part 2, we looked at the use of a vector store as well and understanding the document that we retrieved from the Chroma DB vector store, where we retrieved, let's say in the case where we retrieved just one medical transcript using the exact name of a patient. Then next, we also look at how we implemented the RAG concept in Notebook 2. So in this case, we retrieved the medical transcripts from Chroma database. Then we subsequently created prompts to pass those extracted information to a Gemini model to summarize and process into a format that is easy for a doctor to understand. And next, we also looked at Gen AI evaluation, where in this case, we used the output of one Gemini model to pass into a subsequent Gemini model, which acts as a checker to verify whether the first model's response is following our instructions and requirements. And if not, the checker will also go in to fix the first model's response based on what we want. So that's it for my demonstration of the Google Kaggle Gen AI Capstone. Thank you for joining.